Okay, let's dive right into this explainer by tackling a myth that's so deeply embedded in our minds, it actually became the foundation of modern medical science. Whenever we picture our ancient human ancestors, we almost always conjure up the exact same image, right? You know the one, a desperate, gaunt caveman, constantly living on the absolute brink of starvation, just hopelessly waiting around for the next lucky mammoth kill. It's a gripping visual for sure, but as we're about to see, it fundamentally misrepresents how our ancestors actually lived, and more importantly, how they handled hunger. So, because of that starving caveman image, we commonly just assume our hunter-gatherer ancestors lived in this brutal, unrelenting cycle of feast and famine. They gorged when the hunt went well and then literally starved for weeks. This idea gets repeated so often, it's basically treated as common knowledge today. In fact, it became the working assumption to explain why so many people currently struggle with obesity and diabetes. The logic goes that our modern bodies are simply hoarding calories, bracing for a devastating starvation period that, for most of us in the modern world anyway, is just never arriving. But here is where things get really fascinating. When researchers finally decided to stop assuming and actually test this idea using a massive cross-cultural database of documented hunter-gatherer societies, the data proved something genuinely surprising. The starving caveman is a complete myth. Turns out hunter-gatherers actually experienced famine far less often and honestly far less severely than the quote-unquote advanced farmers who came much later. The lean periods hunter-gatherers faced were typically just seasonal or maybe tied to a quick, localized disruption. Multi-year, life-threatening famines, they were incredibly rare for them. When you compare early agricultural societies to hunter-gatherers side by side, the contrast is just staggering. Early farmers relied heavily on just one or two staple crops, like wheat or rice, grown in fixed locations. And by doing that, they basically traded natural, resilient flexibility for this brittle fragility. Think about it. If a single drought hit, it could trigger mass starvation because their entire caloric intake was tied to that one crop. Hunter-gatherer societies, on the other hand, had highly diversified resources, meaning they only really had to deal with temporary, seasonal lean periods. So if they weren't constantly starving, how exactly did they pull this off? Let's take a look at Section 1, the Ancient Survival Toolkit. The very first tool they used was dietary breadth, specifically something called broad-spectrum foraging. Basically, this was a survival strategy that relied simultaneously on a wonderfully diverse mix of meat, fish, nuts, tubers, fruits, and shellfish. By utilizing dozens of food sources all at the same time, they were essentially spreading out their dietary risk. It acted exactly like a natural insurance policy. If the big game hunt failed for a week straight, there was no panic. It didn't doom the entire group because there was still plenty of tubers to dig up and shellfish to gather. Their second strategy was mobility. Hunter-gatherer groups roamed massive territories, sometimes needing access to up to 500 square miles of land. Now, that sounds like an enormous amount of space, right? But having that room to roam was precisely what kept them alive. If a local drought hit or resources got depleted in one specific valley, they didn't just sit there and starve. They literally packed up and walked away from the emerging food crisis. Farmers completely gave up this freedom the second they committed to tilled fields and granaries. The third strategy was this incredibly clever, careful social engineering. Let's say a hunter successfully acquires fresh food. Well, they don't just hoard it. First, it's shared with their immediate family. But then it gets really interesting. That food distribution ripples outward in highly predictable ways across the entire community. This created an interconnected web of obligation and reciprocity. It functioned as a primitive but highly effective form of risk pooling. It mathematically smoothed out the unpredictable nature of hunting, so absolutely nobody faced an immediate personal crisis if they happened to come up empty-handed that day. Now, the fourth tool in their kit often gets a bit of a bad rap, but it was absolutely vital: scavenging. For a long time, pop science kind of treated scavenging as this embarrassing evolutionary phase, like humanity eating cold leftovers before we figured out how to cook properly. But rigorous research shows it was actually, quote, a smart, deliberate, genuinely reliable survival strategy. It was a low-energy, highly dependable way to secure calorie-dense food, which was a real game changer, especially during periods of actual environmental scarcity. And this perfectly illustrates why humans excelled at scavenging, where a lot of other animals failed. We had this unique combination of biological traits and technological advantages. First off, we literally had strong stomach acid to safely digest decomposing meat and neutralize pathogens. Second, our long-distance walking ability meant we could track down abandoned carcasses quickly, well before they were picked clean. Third, fire and stone tools allowed us to cook the meat and crack open bones to extract incredibly valuable, calorie-dense bone marrow. And fourth, our cooperative group behavior kept us safe while doing the whole shebang. We were extracting calories other animals simply couldn't access. But of course, no system in nature is entirely foolproof, right? So what happened when real scarcity hit? That brings us to Section 2, the biological backup plan. When genuine food scarcity finally did arrive, the human body didn't just rapidly shut down. Instead, it executes this elegant, multi-stage metabolic shutdown process, perfectly designed by evolution to stretch out survival for as long as physiologically possible. In the first 24 to 48 hours, the body burns right through its glycogen and ramps up gluconeogenesis, which is essentially creating new sugar to keep the brain fueled up. Then, after about 4 to 5 days, ketogenesis kicks in, switching the brain's fuel from sugar to fat-derived ketones, and your overall metabolic rate measurably drops to conserve precious energy. Fast forward to a month or more, and the body settles into a stable metabolic reduction, burning primarily stored fat. Depending on your initial fat reserves, this state could actually keep someone alive for months or potentially well over a year. This seriously impressive biological machinery brings us right to Section 3, Rethinking the Thrifty Gene. The absolute crucial point here is understanding the Thrifty gene hypothesis. Proposed way back in the 1960s, this theory basically suggested that our modern obesity epidemic is caused by ancestral genes that evolved to unusually efficiently store fat. The idea was that these genes offered a massive survival advantage to early humans who supposedly faced regular, totally unpredictable famines. For decades, scientists blamed our modern health issues squarely on these thrifty genes, just operating unchecked in today's world of easy food abundance. Honestly, it's a very neat, intuitive narrative. But there is a pretty massive hole in that narrative. What if the famine never actually happened? Think back to the data we looked at earlier. That comprehensive cross-cultural data proved that hunter-gatherers rarely experienced frequent, severe population-thinning famines. And, well, if they weren't constantly starving, then the evolutionary pressure required to spread those thrifty genes across the population simply wasn't there. The entire foundational assumption of the thrifty gene hypothesis completely crumbles to pieces when you actually look at the historical data. So if it wasn't famine driving our body fat genetics, what on earth was it? Researchers like Jonathan Speakman now propose a really compelling alternative. They suggest that initially predation risk kept early humans thin. Simply put, if you were too heavy, you couldn't outrun a predator. But roughly 2 million years ago, the arrival of fire, handheld weapons, and cooperative social defense effectively removed that massive risk. We literally stopped being on the menu. Once that evolutionary pressure to stay thin and fast was gone, genetic variations in body fat were essentially set free. They just drifted randomly across the population, meaning some of us naturally hold on to fat more easily today, and there's absolutely no constant starvation needed to explain it. It totally flips the script on how we view our ancestors, doesn't it? It leaves us with this provocative final thought. Was the quote-unquote primitive caveman actually more food secure than we are today? When you look at their highly structured, beautifully flexible, and deeply cooperative networks, it turns out they were likely far more resilient and secure than the rigidly advanced agricultural societies that ultimately replaced them. The starving caveman was never quite as hungry as we spent decades assuming he must have been, and honestly, that changes absolutely everything about how we understand human survival.